All right, so the big merge is coming, but did you know that not much is gonna change? So my name is Pavel, and today we're gonna look into the whys and hows of the Ethereum merge, especially from like technical perspective, which is what we do here in the channel. Um, but it's not gonna be that technical. There's no code in this one. But still, I would like to get across the substance of the merge itself, so you can have your own opinion about the implications of it. So let's dive in. So in Ethereum merge, the estimated time is around uh, 15th of September. So somewhere around 1 week from now. Yeah. Important thing here to mention that there's no action needed anymore. So there's no like person pushing some code somewhere. The update already happened. It's just that it had like this kind of ticking time bomb in it, and it's estimated to like go off on 15th September. So yeah. So what will actually happen is that we're gonna change the consensus mechanism of Ethereum blockchain, and it's going to change from proof of work, which is what it was now, to proof of stake, which is different consensus mechanism. Thing to note that both of these, proof of stake and proof of work, are already used. So there are chains that run proof of stake, like Avalanche or Polygon, and there are chains that run proof of work, like Ethereum and Bitcoin. But there are many more, of course. So the consensus mechanism itself is not a new thing. The new thing that's happening now is that actually a major chain like Ethereum is going to try to do this uh, like on the fly. So they started with one and they're going to change proof of stake block by block. So there will be last block of proof of work and no interruption, and then there is a first block of proof of stake, which is pretty daunting. So consensus mechanism, this term is a little bit misleading maybe because there are more parts of the consensus that needs to happen. Like there's also the choosing of the longest chain, or like a way of which fork of two chains you want to use. But in this case, what we mean is just ensuring the validity of one block. So if you look at the one block that you're just publishing, is this block valid or not? And for that, we use proof of work or proof of stake. We're providing some sort of proof to say that this block is valid or not. And when I say block, like you have a blockchain, we're gonna see in a minute, but we have all these blocks chained together, and each block contains some metadata about it, like what's not important too much, but it also includes the transaction that's happening, like who's sending money to whom, or which smart contracts are interacted with, and so on. So that's what consensus mechanisms do in this scenario. The proof of work, which is what we're starting from, is kind of interesting concept. How it works is that, uh, again, I have an example here that we're gonna get into soon, but there's this cryptographic puzzle that you need to solve as a miner. So miner is the person who runs those like farms. It's called farms, where they do computationally expensive tasks to kind of figure out what solution to a puzzle to make the block valid. Um, Also important thing, there's a dynamic difficulty. So the difficulty of the puzzle you're solving depends on how many other people are solving the puzzle in a way. So that means that, yeah, that fluctuates basically. Uh, yes. I'm going to talk about gas fees in a second. Proof of stake is a little bit different. So you're not solving any puzzles anymore. What you do is you take your Ethereum and so-called stake it, like you lock it down in the algorithm, and then the algorithm goes around and in some sort of semi-random manner, it chooses people based on their stake to propose the next block. In that scenario, we name these people or these actors validators. So no longer miners, but validators, because they're not mining anything. They're not doing any intensive work, but they're validating the blocks. And yeah, that's what I wanted to say about that. So what's gonna happen actually? Why is it called merge? Is that we're gonna merge. Merge means like, you know, like when you have a car traffic and the two lanes are merging. So that this is exactly the same thing. We have two going chains for what, over a year now. One was a beacon chain, which was the proof of stake chain, which was running for some time. And then we have the mainnet. That's the Ethereum, what was running forever. And at 15th of September, roughly, what's going to happen is that those two chains will like combine into one. And from that point over, we're going to take over the proof of stake from the beacon chain and use that as a consensus mechanism. But we're still going to keep all the history from the other chain. So from the mainnet chain, we're still going to keep the state of everybody's accounts, like all the positions and so on. So that's not going to change, and that's why it's merged, because we're taking stuff from both of these chains. And also, this is not like untested thing. There are many testnet fork. Many of them we use during other videos, like Ringcabby is one that I use quite often, and it's all of these chains were mimicking the mainnet, so they were proof of work before, and they did go through this merge already. Of course, you can never test everything perfectly, but you know they've worked on this for a long time, so it's pretty much validated that it's gonna be fine. All right, so let's go to the example thing, which is this horrible graphic that I made. So this is proof of this is a blockchain. This is one block. Oh, this is one block here. This is another block here. How it works? This is a little bit simplified. That's not how it actually works, but it gets the message across, I think. Let's say that each block has its own ID. Like this is a block 1, this is block 2, and it also has a pointer to the previous block. So that's the chaining part. And in proof of work, what you would do is that there is one more field here that you're trying to guess. So you're trying to guess a number to solve the puzzle, and to solve the puzzle means to make this block valid. So you can guess maybe 10, right? You guess number 10. And how you can tell the block is valid or not is that you add up all these numbers, like including this ID, and there are a bunch of other numbers. And if the resulting number is something, like say if it's an odd number, then the block is valid. So to do the verification, if the block is valid or not, is super easy. Like it takes no time at all. But the other way around, if you need to figure out what number to put here to make the puzzle valid, that's just not feasible. So the only way you can do this is kind of brute force it. So you try and get different numbers. You try 10, no, doesn't work. So I'm going to try 11. That doesn't work as well. I'm going to try 12 until I find a number that actually works and that makes the difference. That makes the actual block whole. Now, this is pretty cool. But we also said that basically the difficulty increases with how many people are trying, because that's the important metric here. If you have a very powerful mining rig, or like a mining machine or mining node, you can try much more combinations than, you know, the guy next to you. So that means that you get many more shots on the goal, and then you're more likely to actually win this battle and win the next block. And the first person that wins the next block is the one that's gonna publish it, and they gonna the reason they're doing is because they're gonna get a reward. They're gonna get some Ethereum back. So it's this competition, and then basically the amount of electricity we put into this. So to do these the tries to shut off the goal, what you need is like powerful GPUs, and they need a lot of electricity to keep going, like to keep trying, and and the amount of electricity you as a miner is willing to pay towards this rig is basically needs to be less than what you're gonna get in the reward, right? So that means that if the price or if the value of the reward is gonna rise, you are willing to pay more electricity into this. So if the price of Ethereum goes up and you're still getting, I don't know, 0.01 Ethereum, then you're willing to pay a little bit more on electricity, which is why all of these proof of work chains consume so much electricity, because especially if the underlying asset, like the coin itself, value rises, uh, the people running these rigs are willing to pay more for electricity, and that way they're gonna consume more electricity. So that's why the electricity comes in the play here. And also the more quickly they solve the puzzle, which is like a proxy measurement of how many people are trying, right? If there are more people trying, that's or like more computation power rather trying, and more quickly we're gonna get the result. And the algorithm will automatically adjust the difficulty of it. So in example, we said we're looking for like an odd number, right? But it could be, let's say, if I divide by 10, it needs to be like it needs to be integer division. So there's no uh, remain, I guess. But if you want to increase difficulty, you want to divide by maybe 2. No, the other way, like 13, and it's still no remainder, right? So that was proof of work. This was the toughest part. If you made it that far, then let's go to proof of stake. So proof of stake is people will stake their coins, right? So I will stake my 10 coins, the guy next to me will stake their 10 coins, and the algorithms will just semi-randomly choose me or the other person to publish the next block. And in advance, you know that you're supposed to publish the next block. So you will just say, okay, so my address is this 124, and the algorithm knows that this is the actual producer that is supposed to publish this block, uh, and it's a valid block, right? So that's how it works. There's no like puzzle, there's no computation, it's just that person is supposed to do it, he did it or she did it, all good. Cool. I hope that's clear. So what are some implications of this? We already talked a little bit about that. The energy footprint will go down. That's because you no longer do this computation, right? You just stake your ETH, which is one-time action, and you just need to keep your computer running. But it doesn't even. It can be like a Raspberry Pi. It doesn't even need to be a powerful machine at all. The only requirement again is the hard drive requirement, because you need to store the history. But yeah, that's not the energy complex thing to do. In a way, it's easier to participate because again, you don't need these graphic card mining rigs, the expensive ones. You just need a simpler computer with big hard drive. But as same as before, you can always join some sort of pool. So you just send your Ethereum in that pool. But now it's more transparent, like you just send the Ethereum and they're actually going to stake your Ethereum and then run the node. Otherwise, you would kind of pay them and they would run the computation for you, which is a little bit, different. But you can still use the pools, right? There's also this concept of lower issuance of Ethereum. The way how we reward these miners is partially from gas fees, depending on some other variables, but partially also we like issue new coins. So it's the same like Fed is printing dollars. So Ethereum is also printing some Ethereum and then giving it as a reward to miners. It's this number of how much they issue of this Ethereum will go drastically down. Like, yeah, quite a lot down. Like you think of it as I think it's said that it's like 3 halfenings. So it should be like 3 times 0.5 or something like that. but I don't know the exact number. Anyway, it's gonna go way down. This doesn't have much technical like impact on us. It's more like economics or tokenomics impact, because now the token itself becomes more deflationary, uh, which is like economically interesting term, but not that important for us, really. And now what's going to stay the same? You can see the list is a bit longer, but I've written the list, so I could have chosen which one's going to be longer, right? A lot of things will stay the same, actually. So one important misconception is that gas fees will go down, but they won't, right? They will not change. Um, the amount of gas fees you need to pay for your transaction to go through mostly depends on one thing only, and that's like it's a supply and demand. These blocks that we're publishing that we saw before, they have some amount of space, so they can put so many, only, I don't know, say 10 transactions. Um, and then these blocks are published in a fixed interval. So every 12 seconds, say, you get to push 10 transactions. Uh, this pretty much doesn't change. There is a little bit variation of it, like there's a little bit of change, but it's not nothing really impactful. So it's still gonna be same interval. The size is gonna be the size is gonna be same, and the interval is gonna be very similar. Uh, so we're still gonna be pushing these blocks out the same size. So the supply doesn't change. Demand also doesn't change. Like people are still gonna be using it. You need it for your DeFi, the NFT projects, the gamify stuff. All will stay the same, and you still need to go ahead and pay more gas fees in order to be included in the next block. You can check out the video about the MEV, like maximum extractable value, where we talked about bots, because most of the transactions that take these supply the transaction spots are actually bots. It's not people. So that's a thing to mention. Yeah, and with this is related that there are no scalability upgrades. So there's no, as we said, there's still the same space, similar intervals. The long-term goal, there is a sharding coming up in Ethereum. It's not gonna happen now, but it's in the future. And but the long-term goal of Ethereum is to go with the layer two solutions for the scaling. So what they plan to do is to make it easier for layer 2 to kind of group transactions in one and put it in the main blockchain. That's how layer 2 works. So they do their own thing. You do a bunch of transactions in their system, which are super cheap, super fast, and then they package them together to one transaction and roll it up to the main Ethereum network. That way you still have the better of two worlds. So you have fast transactions with cheap stuff, but you also have the security of Ethereum that nobody can like change the history and stuff like that. Yep. Which is in contrast with, let's say, Solana, which is on the opposite side of spectrum. Solana is just going for very fast transactions on the layer one, uh, and they're sacrificing this security of history a little bit. Also, the stake that we talked about in a proof of stake is still unstakeable. So you can put stake in, but you cannot withdraw it. That was true before the merge, like for the past year and a half, and it's also going to be true after the merge. From my understanding, it's going to be roughly 1 year since we will be able to unstake the Ethereum we have staked. That being said, some providers like Lido or even Binance, the centralized exchange, they have a staking offering. Um, what they do is that you deposit your stake there and you get another token in return. And that token is tradable. So that token you can trade on pretty much, it's just a little bit lower value than the Ethereum itself, because the expectation is that this token will be reclaimable for the original Ethereum. So it's not like you don't get to sell off your position at all. It's just that you could lose part of it. But again, depends on the pool you're staking with. If you do it yourself, you can't do that. You can't unstake in any way. And no action by users or developers. So for users, we said the state of the blockchain stays the same. So you still have your, Ethereum position. You still have your loans in Compound or whatever. Everything stays the same. And developers also, the EVM, the execution layer, the Ethereum virtual machine doesn't change. So all the commands work the same. Nothing is different there. And we mentioned that the state is not changed as well. Cool. Well, thank you for your attention. And then just to wrap up, if you would have an idea of what I should be talking about here, just write it in a comment, please, or just let me know. Come chat on Discord. There's fun times to be had there. And have a very good day. Bye.